Good morning, everyone. Can you hear me okay? Excellent, thank you. So, welcome to week two. This lecture is going to focus on actually teaching you how to code this time. So, I know last week might have felt like a bit of a weird lecture. It was mostly about just orientating you to the subject, and we spent very little time on the actual, lecture part where we teach you how to code. So if you came away last week feeling a bit unsatisfied, all you really learned how to do was print stuff to the console, system.out.println. Uh, this week we're going to do much more actual coding, and the focus is definitely going to be on learning how to code in this lecture and all lectures going forwards. Um, also, I apologize if you hear a bit of noise this morning. So my 2-year-old is sick and at home. Um, if you've got a 2-year-old at home, you would know how I feel. He's basically a petri dish. He catches every cold in existence when he goes to daycare. So he's homesick today. My wife's going to take him to the doctor in a little bit. He was homesick yesterday, and I was looking after him yesterday, which is why I didn't catch that stuff about uh, the post in the discussion board about the material not being available. So I apologise about the material not being available and not catching that until the evening. I'll try to do better and make sure everything's released first thing Monday morning going forwards as well. Okay. So like I said, this week we're going to be learning all about variables, types, expressions. If you've read the readings already, you probably haven't because they haven't been up for very long. But it's this lecture is going to be kind of covering the same stuff as the readings, but the reason we do both, we have both the readings and the lecture, is one, different people learn in different ways. Some people find it really easy to learn by reading and going at their own pace. Other people find it really difficult and prefer a lecture format. But also in the lecture, we're able to do more interactive stuff. I'm able to slow down and repeat stuff and reframe stuff if I'm getting lots of questions in chat, whereas the readings are kind of just there, and if you don't understand the reading, you're kind of stuck. So they're both supplementary. I recommend you do both. But yeah, today we're doing the demo reading, and if there's anything that doesn't make sense during the lecture, definitely say so in chat, and I'll try to reframe it in chat. But if we're running low on time, there's definitely a lot more detail in the readings, so make sure you're covering those as well. Okay. Before I get started with the lecture, just feel free to ask any burning questions in chat. I just want to address one question, which was about whether the lecture slides will be uploaded to Canvas or Ed. The lecture slides aren't going to be uploaded anywhere, and that's a considered decision. That's not just because I'm being lazy. The lecture slides aren't really designed to be self-explanatory. So if I just give you the lecture slides, they're not really that great to learn from. And every time I do that, students think that they can just burn through the lecture slides and then not watch the lecture, which is really bad. It doesn't work that way. So instead, you've got two options. One is that the readings are self-explanatory, and a lot of the same, diagrams and stuff are in the readings, but they're given a decent amount of text to explain them. Or the other option is, as soon as this lecture is finished, the live stream, the lecture recording goes up live on YouTube. And I haven't had a chance to do it yet, but after the lecture, I tend to add the little section headings so that, if there's a particular part of the lecture you want to revise, you can just jump to that particular chapter of the lecture. And again, that'll be self-explanatory because you'll have me explaining the slides as I go through the lecture. And, you can just bump up the speed to 2 times or 3 times or whatever, and listen to me sound like a chipmunk while I'm talking. Okay. Some other questions. I'm learning Python for another class. I was wondering how similar it is to Java. Where are you learning Python? If you're learning Python in Programming 1, I would suggest you only do Programming 1. It's a bit of a waste of time if you're doing both Programming Fundamentals and Programming 1. But if you're learning another subject, no worries. They are quite different languages. And the main thing is, if you've checked the reading from last week about, what is Java and why do we choose Java, there's a couple of things why we chose to teach Java in this introductory subject is it's strongly typed. You'll learn about types in this lecture. And it's also strongly object-oriented, which you won't learn about until like week 8. But those two things are not true for Python. Python is not strongly typed and it's not strongly object-oriented. So it's not a good choice as your first language to learn, or it's not what I would recommend. More professionally, they get used for different purposes. If you're a data scientist or a machine learning person, you would 100% be doing most of your work in Python. All of the best machine learning AI stuff is in Python. But if you're a web developer, particularly if you focus on the back-end web development, meaning the stuff that runs on the servers, the stuff that provides APIs and that kind of thing, you would be doing, most people do that in Java. So there are two different languages that are used for different purposes. I can't really go into more detail about that. There's lots of resources you can Google as well about just go Java versus Python and you'll see lots of resources. About the due dates for the lab, let me cover that at the end of the lecture. I'll have my usual housekeeping section where I'll talk about what's due this week. In terms of what about notes, I still recommend, like, the slides are not a great source for notes. I would still instead recommend taking your own notes based on, compressing the readings. I still feel strongly that the slides on their own are not a good resource for students. Okay, network fundamentals, that makes sense. Cool. Where can I find them in YouTube? So you're on YouTube at the moment, you're looking at this lecture. The same link is going to work for viewing the recording afterwards. So you don't have to do anything special to view the recording afterwards. You can just find them by the same link. So we don't have to take notes on last week's lecture. So none of that stuff from last week is going to end up in the exam or anything like that. It was more about how the subject works. But it's important stuff to know. Like the stuff from last week, pretty much all of it is in either the subject outline or the Getting Started module in Canvas, or in the Everything You Need to Know About the Subject section in ED. So, like, as long as you feel on top of it and feel comfortable that you're not going to miss out on marks, you know what all your assessment dates are and how things are going to be assessed, you don't need notes, but, it can be good to organise at the start of the session, make your notes about what you need to do to succeed in the subject. Up to you, really. Okay, I can't find the readings. Okay, let me jump onto that then. So this was covered last week in the lecture last week. But what you need to do is, let me jump over to my slides, my browser I mean. Okay, so in ED, okay, let me go all the way back to the first place you probably go to for the subject is Canvas. And from there, we don't really have much on Canvas compared to other subjects. We use ED instead. So you need to go to ED in the sidebar. And then from ED, the main places you need to be, you'll start off on the discussion board where you can post up questions and get help that way. And then the other main place you need to know about is the lessons page, which is this picture of a person looking like he's reading a book. And in there, this is where all of the readings are going to open up. So far we've opened up readings about how the subject works, the stuff from last week about learning about the basics of what is programming and the elements of essential elements of a Java program. And then this week, it opened up a little bit late. It was intended to open up first thing Monday morning, but I opened it up Monday evening, which apologies for that. But these are where you'll find the readings. So you find the lecture entry and then the readings. Consider these ones to be essential reading. Everybody should be reading these ones. And then this one is just an optional reading if you want to extend yourself and understand a bit more about Java programming. Okay, and this is where you'll find the exercises for the lab as well. All right, we'd better get started. Okay, so we've got a fairly busy lecture going on today. So this is going to be a bunch of buzzwords, variables, types, operators, expressions. If you haven't had a chance to follow the readings yet, and most of you would not have because of how late I was posting them up, you'll understand what these words are, and you'll understand what these words are by the time we finish this lecture. But these are all definitely essential things that every programmer needs to know about. You can't write a program without knowing about these things. I'll do my usual housekeeping. If you don't remember from last week, housekeeping is just my word for, essential announcements, what's going on in the subject, what's due, what you need to know this week. So I'll cover that. I'll be talking mostly about how labs are going to work this week because this is the first week that labs have opened up. And I'll do most lectures, I'll do a quick little recap of what we covered in the previous week. Just focusing on the stuff that we're going to build on again, that if you missed it last week, you will have trouble following along this week. So for the recap, obviously most of last week's lecture was about how the subject works. I won't recap that because we really talked about it to death last week. And all of that information, if you missed it or if you have any things you need to clarify, the number one resource you need to look at is the subject outline, which again you can find back in Canvas. And just go to subject outline. That's got all the information about the schedule for the subjects and the assessment tasks and their weightings and that kind of thing. Oops, I won't bother switching the screen for that. And then the other thing, the more important bit to recap is what I talked about how Java programs need to be structured. So let me quickly recap that part, because we're going to write some Java code here today. Okay, so this is going to be a different program this week that I'm going to build, but last week we had a similar looking program at least. All Java programs start out looking the same, which is that we need a class and we need a main method inside of that class. You don't need to worry about how to create a class or how to create a method just yet. For now, every time we need you to write some code, like in all of your lab stuff, you're always going to start out having a class created for you and a method created for you, and your job is just to change the code that's inside the method. So don't worry about if this stuff looks like gibberish or this stuff looks like gibberish. We'll cover this bit in probably about week 7, I think, and this bit in about week 8. But until then, we're just focusing on the stuff that happens between these two brackets, which is basically opening up the start of the method and the end of the method. We'll be focusing in here. all of the stuff I'm going to do this week is going to be inside of this area. But just to give you a brief preview, a class is like a package of code. So we're going to create a package of a code called variables. And inside of that, inside of a class, you have methods, where methods are something where you can say, I want to run this method, I want to give it this input, it might or might not produce this output, but do the stuff in between this brackets to take this input and do something with it. Every Java class has, every Java program, unless you're working in some special frameworks like Spring that we won't go into in this subject. Apart from that, every Java program needs to have a main method, which looks like this, that is called main and has this kind of input stuff here. Whoops. Because that's the computer's footprint into the program, as in that's its starting point, that's its, not footprint, toehold, like, you know, that's where it will always start the program in. And you might call other methods from inside of this main method, but every Java program is going to start by calling this method. Okay. Okay, let's start off talking about variables now. So variables are basically the way your computer program remembers anything. So they're completely essential. It's completely unthinkable that you would ever try to write a program that doesn't have any variables, unless you're programming in some weird non-functional language or something like that, like purely mathematical language. Even then you'd have variables. So yeah, you would always have variables anytime you're coding. So it's the first essential thing you absolutely need to know about and need to understand. So if you need your program to remember something like your user's name or their age, or whether they're an admin user or not, or what they typed into your when you asked a question or something like that, you're always going to use a variable to store that information. Even if you're only using it temporarily, you'd need to store it temporarily. You would use a variable to do that. Before I explain how to actually code with variables, it's worth thinking about it under the hood for a little bit. I won't go into a huge amount of detail, but just the essential stuff you need to know to understand how variables will work. I'm sure everybody knows that a computer consists of, you know, a processor, a CPU, which is what actually, you know, executes instructions on your computer. You've got a hard drive, which is like for long-term storage. You know, if your computer turns off, anything stored in the hard drive will still, it won't disappear, it'll stay there. And you've got memory, which is like short-term storage. When you're programming, you really don't have to think much about the CPU. Like, the CPU is just the thing that executes the instructions. If you were doing like really low-level coding, hopefully you've read the readings from last week, you know what I mean, but the difference between high-level languages and low-level languages. If you were doing low-level languages like actual machine code, you'd have to write code that loads instructions into the CPU and then downloads results out of the CPU and stuff like that. But high-level languages like Java, or, you know, anything that any sane person uses, lets you not worry about the CPU at all. So we don't have to talk much about the CPU in the subject, at all in the subject. The hard drive, you know, you definitely want to write programs where, you know, it doesn't just forget everything as soon as the program exits or anything like that. But so as a developer, you will have to deal with the hard drive. You'll have to deal with, you know, loading stuff from files, loading images, storing data in a database. That kind of stuff is all what I say is, you know, interacting with the hard drive. But we won't do any of that in this subject actually. So that's going to be a topic for later subjects or your own ongoing research. We do have some optional readings in like week 12 about how to read to file, write to file, read from file and stuff like that, but you're not going to have anything that's assessed about how to interact with a hard drive. So the main thing we've got to worry about is the memory. And the main way you interact with the memory, this is how your program is going to remember things. It's stuff that the user types in, stuff that the user asks for, decisions that need to be made. How it remembers all of that kind of stuff is through variables. And a variable, it's basically just a little chunk of memory that you reserve for your program to use, and you reserve it with a name. So, let's say this memory here, I've just represented it as a grid of blocks, and each of these blocks is capable of storing a piece of information. So when our program needs to be able to store information, what we're going to do is basically say, this block is mine, no other programs are allowed to use it, I'm reserving it for my use. By my, I mean the program's use. And when you're programming, you reserve that spot with a name. So I say, I'm going to call this memory location X, or I'm going to call this memory location student name, or I'm going to call this memory location ride fare. And that's just, the programmer has complete control over what they call their variables. Obviously it makes sense to call your variables by sensible names so that you know what they're for as you're writing your code. So obviously this variable this memory location is going to be used to store a person's name, or this is going to be used to store some dollar amount, how much it costs to get an Uber fare or something like that. Whereas this is not a super useful name, I have no idea what X would store. But you as the programmer have complete control over what you call your variables. And you as the programmer can put values into those memory locations. So you can say that, X, that memory location has the value 3. I've stored the number 3 in that memory location, or I've stored the name Bob Bobson into this memory location, which is available to me under the name student name. So you can do things like, X equals 3 is basically putting the value 3 into that memory location, or, X times 2 would be fetching that memory location, that value at the memory location, so 3, multiplying it by 2, that would give you the value 6, things like that. So you can put values into these memory locations, and then you can use those values later on in your program to make calculations or update decisions or give output to the user, that kind of thing. So now let's do a little bit of programming for how these variables work. So when we're working with variables in Java, actually, before we do a little bit of programming, I've actually got to cover one more thing before we do that actually, so let me go back. We can't start talking about variables until we've talked a little bit about types. Okay. So types are, each variable needs to have a type, especially in a strongly typed language. Remember I talked about how Python is a weakly typed language, Java is a strongly typed language. In Java, every variable that we create, we need to explicitly, manually say what the type of the variable is. And so we have a bunch of different types that are available to us. I've got a slide in a couple of slides' time listing the different types that you've got available. But just to give you a teaser, like we've got a type that is int, short for integer. which is useful for storing whole numbers. If you have a number that has got no possibility of having decimal places, if it's somebody's age, for example, or the number of students in a class, that you're not going to have half a student, then int would be a good type for storing that data. That's opposed to double is a good type for when you have things in the decimal places. So if you're storing currency values or the results of scientific calculations or lengths or uh, durations or that kind of thing, you would use a double. Or string is a good type for the main type. The only type you would use it for storing text, like somebody's name. And you have to choose the right type for the data that you want to store in your variable. So, like you could put the value 3 into a double, but it would be storing it internally as 3.000 or whatever. You couldn't put 45.75 into an integer. An integer is only capable of storing 45 or 46. You could store 45.75 into a string, but it'd be treating that as, the character 4, the character 5, the character dot, the character 77, and the character 5. And it wouldn't know what those characters mean. It wouldn't recognize them as being a number. It wouldn't be able to do any maths with that as a number. So you have to choose the right type for your variable. Java distinguishes between what are known as primitive types versus non-primitive types. Basically, there are, in Java and in other languages, theoretically there's an infinite number of types that you can create because you can manually create your own types. But all of those types you would create would be based on using, changing, altering, combining a subset of types which are the primitive types. And you can easily distinguish between what are the primitive types versus the non-primitive types by whether they have a capital letter at the start of them. So an int is a primitive type, a double is a primitive type, a string is a non-primitive type. We'll go into more detail about the difference between primitives and non-primitives, especially when we start talking about classes. But for now, we're mostly going to focus on only the primitive types, because there's a very limited subset of primitive types that you need to know about. And we can't get away from using string. Like, we need to be able to store text in pretty much all of our programs. But string is the only non-primitive type that we'll be talking about for quite a while. So, in terms of the primitive types, this is the full list of primitive types that Java makes available. And so there's not that many. There's only 1, 2, 3, 4, 5, 6, 7, 8 primitive types. But even that, we don't need to know about all of them, because honestly, half of them I never use, and I won't force you to learn about stuff that is not super useful. So really, we can cut this list down to just 4 primitive types that you really need to know about. The first primitive type is Boolean, which is for storing the value true or false. So it only has 2 possible values. It's either true or it's false. That's really useful for storing things like the results of, if you're navigating a flowchart, do you go left or do you go right? Did they answer yes or did they answer no? Or making decisions around, are they registering users? Are they over 18 or under 18 or whatever you need to do? You can use Boolean for that. Char is just for storing a single character. Honestly, that's not a really useful type because most of the time you want to store more than just one character. You want to store a string, a sequence of characters, in which case, we use that string type instead. So you're going to use string way more often than you use characters. but it's a useful concept to know about because we are going to talk about the first sort of more complex type we're going to talk about is how to combine values into lists of values. It's very often useful to create lists of values. And you can think of basically a string as a list of chars. So, yeah. You won't need to deal with individual chars very often. Char is short for character, obviously, but they're good to know about. Ints, as we've already said, are useful for storing whole numbers, and doubles are useful for storing decimal numbers, numbers that can have fractions, can have things after the decimal point. Okay, let me pause there for questions. Any questions about what I've covered so far? So float and double have the same functionality. Yeah, basically, sorry, that's what I mean by these lines here, is that all of these types, byte, short, int, and long, are for storing whole numbers. Float and double are useful for storing decimal numbers. The only difference between them really is that, okay, so for float and double, it's called a double because it has double the precision of a float. So a float can store decimal numbers, but it can only store them up to a certain precision. It can only store them up to a certain, decimal, what's the word called? Those of you who have done high school maths more recently than me will know what I'm talking about, but it can only store the numbers to a certain level of precision, whereas, double can store it to significant figures, exactly. Whereas doubles can store double the amount of significant figures. And so the only thing you gain from using a float instead of a double is a little bit less memory usage, or half the memory usage, but no one cares about memory these days. Unless you are working on really tiny embedded devices, you'll have plenty of memory to work with. So only in very limited cases is it worth talking about floats, and so I just won't bother doing it in a foundation subject. Similar with integers, bytes and shorts can only store a certain, up to a certain, within a certain range of numbers. Integer ends up being the most practical number. I think there's full details in the readings about, how much precision this can handle versus this, how big a number or how small a number you can store in this versus this. But integer ends up being the most practical one. Longs can obviously store much larger or much smaller numbers than integers, but you don't tend to need them very often. So in most cases, integers are just fine. Is Java case sensitive when declaring type? Yeah, that's a really good question. Java is very, very strict, very much case sensitive. I think it's a good time to move on to programming actually, and then I will we can demo out some of these questions and how Java will complain if you try to do things wrong. Okay, so let's create a variable. Let's just create some of those variables that are in that slide example actually. So if I want to create a variable that is called x, that is capable of storing the number 3 or 4 or a whole number, I want to make it an integer type, I need to type the type first. So int or string or double or whatever. So is the type first, and then the name of the variable. So x or y or z or num or whatever. And that is basically what that piece of code is, what that statement is doing, is reserving a variable with the name num or the name x with a type integer. Obviously, different types need a different amount of space to store things. Like, a double is going to take more memory than a float, so it has implications about how much memory you're reserving, but you don't really need to worry about that. You just need to say, I want a memory location that I'm going to call X that is capable of storing integers. And then once I have that variable declared, this is the code for declaring it, basically reserving that memory location. I can then go on to use that memory location. Like I can set that value to be x equals 3. I can print that memory location. This is just that code from last week. Right? If I compile and run this code, remember from last week, if you're confused about what I'm doing here in terms of compiling and running the code, the readings last week about what the difference is between source code that hasn't been compiled yet and machine code that has been compiled yet, you don't really have to worry about that. Anytime we ask you to compile or run code, all you need to do is just hit the run button and it will do that for you. But when I'm outside of those preset challenges, I need to manually compile and run my code. So let's compile it. And let's run it. Okay, so it's declared that variable, it's put the value 3 into that memory location, and then printed out the results. You can, and it's very common, to combine both the declaration step and what's called the initialization step, which is giving it its first value in one step. You can just do it in one thing here, and this will behave in exactly the same way. Okay. I can do anything I want with that variable now. I can update it, so I can say x is now 5 instead of 3, and you can imagine, I'm sure you know what this is going to do. Okay, and it's going to now, by the time I get down here, x now has the value 5, not the value 3. In case it's not obvious, it probably is, but in case it's not obvious, when I'm running the program, it's running sequentially from top to bottom. So it runs this statement first, and at the end of this statement, we've got a memory location. By the time the statement has been run, we've got a memory location called x that has the value 3, and then we change it to 5, and then we print it out. So like if the order that I'm making these statements matters. If I do this instead, I'm going to get a different result. Okay. Medicine. So there's practice exercises in the, you definitely want to practice this stuff. We have some practice labs this week. You'll find it in the ed lesson. So the practice that we've intended you to do that's going to run you through the stuff is in the practice lab. You can do this stuff in your own time if you want, but it's mostly suggested that you do it during the labs. And at the end of the practice lab, there's an entry that explains how you can generate new practice tasks with ChatGPT. And the main thing you'll need to know if you go outside of the preset practice tasks is you need to know how to use the workspace stuff that I'm doing here. And that's covered in everything you need to know about ed under how do I use workspaces. But this is kind of advanced optional stuff, just if you want extra practice on top of those preset practice tasks that we've given you. Also, you can, I haven't shared this yet, but inside the ed entry for this lecture, you'll find a link to the workspace that I'm working on here. And you can actually make your own changes to this workspace, and basically you'll do what's called a fork, which is where you take what I'm doing here and you make your own copy, and you can freely make any changes you want to what I'm doing here. I see people jumping in. Cool. Z, will global and local variables be covered in this session? Java has a bit of a different take on what global and local means. We'll start covering that more when we cover classes. It doesn't really make sense to think about it at this stage. At the moment, we're only going to talk about local variables, meaning these variables that I'm declaring here only exist inside this method, but it's going to be quite a while before that distinction matters, because for quite a while, up until like week 7, everything's going to be inside of one method. So you don't need to worry about the difference between global and local for a while yet. Samson, for this subject, don't worry about downloading Java. You can compile and run Java code inside of ed, and that's much easier. In week 12, I will share some instructions for how to do programming outside of ed, but it's not something to worry about just yet. It's not you'll spend all of your time sort of setting up your system if you try to do stuff on your own computer. It's much better just to learn inside of ed for now. I understand you would want to do stuff outside of ed in future, but we'll cover that in like week 12 as basically, how to keep programming after the subject is done. Okay, so some things to keep aware of is that, like I said, Java is case sensitive. So if I make this a capital letter and try to compile this, it'll say cannot find symbol. This is a very common error you'll see a lot of when you're coding. You'll find errors like this. What it's basically saying is that Java is saying I have no idea what this means. I don't know what int with a capital I means. So it matters whether it's a capital letter or not. Same with string. Like if I declare a string variable, string is Bob, this will work. Okay, but if I make this a lowercase letter, it doesn't work because it doesn't know what string with a lowercase means. In terms of when you're naming your variables, you can name them whatever you want. You can name them capital X if you want. It's generally accepted best practice, just because you want to be able to tell what's a variable versus what's a class or what's a type when we come to that sort of thing. It's generally better to keep your variables starting with a lowercase letter, but you can call it capital letter if you want. The only implication there is you just need to be consistent about how you name it. So this line is going to be fine, but the lines that actually try to use X are not going to be fine. So also I need to explain how to read these error messages. So these error messages are messages saying that the compiler can't compile your code. It's not recognizing it as valid code. And so these messages are saying, in this class, variables, at line 7, so on line 7, I have this problem with the code. I can't find this symbol, and it's also got a little pointer to the exact location of the error where the problem is. So it's saying on line 7, I have a problem with this thing. I don't know what string is, so we can fix that one. And down here on line 11, I cannot find symbol X. I don't know what lowercase x is. That's because we called it uppercase X up here. So on this thing, on line 11, I called it uppercase X up here, so I should again call it uppercase X up here. And also I missed out on one here on line 9. Up here I called it, I need to call that uppercase X as well. Okay, I've successfully compiled it and I can run it. Okay, got a question. When would you use Boolean as a variable? Whenever the thing you need to store is either true or false. So, Boolean What's a good Boolean? Is student equals true. Okay. So, you know, say I'm building up some knowledge in my program about this username, say. And so I'm building up data. I know what their name is, and I know whether or not they're a student. You know, this makes sense to store as a string because it's their name. And then I could say int age equals, you know, 24. Integer makes sense to store their age. Boolean would make sense for storing whether they're a student or not, or anything that can be boiled down to either true or false. It happens more often than you think, and it will especially happen a lot next week when we're talking about conditions, which is basically how you make your code do different things depending on whether the person is a student or not. And that all boils down to dealing with Booleans, things that are either true or false. Okay. How do you write it so the variable is in the middle of a sentence? Okay, this is kind of an example here. So we're combining text with a variable. And you can add more information to that. Like that, and that's going to combine it put it in the middle of a sentence. I'll get into more detail about what this plus sign is doing in a second, actually. Okay, but it's putting the value of that variable in the middle of a sentence. Hopefully that's what you meant by putting it in the middle of a sentence. Can char store a number? Yes, it can. So we can go char y equals 4, and we can go let me just copy paste. Okay, but it's storing that number as a single character. So for instance, it can't do that because this is 2 characters. So it gets an error here where it can't store 2 characters at once. You could store that as a string, right? That gets over that issue. But in that case, we need to use, by the way, you don't deal with chars very often, but when you want to have a char value, you need to put it inside single quotes. Whereas if you're dealing with strings, you need to put it inside of double quotes. So we can do that, and that's capable of storing those 2 characters. Right? But this would be a bad idea because it's not recognizing this as a number, it's recognizing it as a integer. Sorry, as a string. So for example, you know, let's do this. Okay, so let's print that out. Okay, so we're storing the age as a number. We wouldn't want to store that as a string because, you know, next year if it changes, we want to say age equals age plus 1. You know, we want to increase it. We can do that if it's a number, right? Bob's age is now 25. But we can't do it with this one. If we go y equals y plus 1, it's not recognizing this as a number, so it can't, you know, it should be turning that into 15. It's not smart enough to do that. it's just sticking the character 1 at the end of 14. So now their age is 141. So that's kind of an example of why types matter, is because, you know, here when we're using this type, this thing is adding 1 to the number because it knows that this is an integer, it's a number. Whereas here it's sticking the character 1 at the end of this sequence of characters because this is a string. So the plus operation means different things depending on what type your variable is. But we're actually, that's the topic for the next set of slides actually. So let's get on to that one. Okay, so operators. Operators are operations that you can perform with your variables. There's a bunch of different operators. We've already seen a couple. We've already seen the equals operator, or the assignment operator, and the plus operator. But it's worth going into a little bit more explanation than that. Okay, so the first operator you're going to use a lot of is the assignment operator. We've already used it a fair bit. And just to explain what that operator is doing, whoops, it is basically saying, it's the assignment operator, meaning it's taking whatever value is on the on the right-hand side of the operator, the equal sign. It's got to take that value and put it into the variable on the left. Okay, that's strictly what it's doing. And the thing on the left-hand side always needs to be a variable. It always needs to be something that can accept a value, something that can store a value. But the thing on the right-hand side could be just a value, or it could be a variable, or it could even be the result of a calculation. So we've already got some examples of that in our code. Let me jump over to our code. So here we're using the assignment operator to take this value on the right, value 5, and put it into this variable. Or here we are again taking this value on the right and putting it into this variable. But here we're taking the result of this calculation and putting it into this variable. Okay? And you can combine multiple values like in this assignment operator. So for example, you know, x equals 5, let's make this an integer instead so it's actually sensible. And we want to say, we don't want to declare a new variable, int z equals, sorry, I'm pedantic, I have problems having capital letters in my variables, so let me fix all of that as well. Z equals x plus y. Oops. Okay, so z is the result of adding together 14 and 3, which is 19. Okay. Sorry, 5 plus 14, which is 19. Okay. Let me just check on questions. So if I want to output 14, I have to use int instead of char. Well, the number 14, because it's a whole number, you should be thinking, I need an int to store that. That's the only sensible thing to do with the number 14. You could put it in a string, because a string can handle multiple characters, and the number 14 is made out of the character 1 and the character 4. But if you did that, you wouldn't be able to use maths on it. Can an int variable automatically increase based on time, as in coding a stopwatch? You can. So there's plenty of this lecture is only going to go through a very limited number of operations or values or things like that. There are ways that you can get the current time from the system, and you can put that value into an integer, or that's one of the few occasions where you want to use a long, because the times that you get from the system, they're normally millisecond and milliseconds, so you need really large numbers to store that. But yeah, you can totally do that, and you can totally increase it over time or decrease it, or whatever. You can do a lot of maths. Jessica, yep. So I haven't. Let me go on to the next slide. Is actually talking a bit more detail about how the plus sign works. So, sorry. Let me keep going with the slides. I think. A twitchy eye for some reason. Oh, okay. Before I move on with the equality sign, there is one extra note that I need to make, which is, okay, let me set up a scenario for you. Okay, so let's say x is 5, and let's say, yeah, x is 5, y is 3, is x plus 10, right? And then let's change the value of x to be equal to 10. And we'll print out the value of y. Let's print out the value of x and the value of y. Okay, I'm going to comment out some stuff. By the way, another thing that's very useful to know about are comments. So what comments do is you just start a line, if you want to create a comment, you just start a line with // and then you can see Ed has turned that text into gray. And that is useful for creating things like, you can create notes in your program, like this is something like that. What comments are basically code that will be ignored by your compiler. They don't do anything, they only exist to sort of add notes and explanations. But the other thing they can be useful for is just temporarily disabling lines of code. Like I'm basically making this line into a comment so that I'm not going to do these lines. And let me just use that to kind of simplify, get rid of some stuff that I don't want to happen right now. So now, basically, the only thing we're doing in our code now is we need our variable declaration, but we're going to set x equals to 5, and we're going to set y equal to x plus 10, and then we're going to change the value of x. So when I run this code, let's get some votes in chat. What do you think when we get to line 24, what do you think the value of x will be? And what do you think the value of y will be? So we've got y will be 20, x will be 10. We've got x will be 10, y will be 15. X equals 10, y will be 15. 10, 15, 15, 10. Yeah, okay, so most of you are right. So remember, these statements happen sequentially. So here, x is going to be 5, and then we're going to change y, we're going to set y to be x plus 10, so 5 plus 10 is 15, and then we're going to change the value of x to be 10. Those of you who are thinking in terms of mathematics and algebra would then probably expect y to be updated. When we change the value of x, you would expect y to be updated to be, 10 plus 10 would be 20. But let's see what happens. So instead, we've still got x is 10 and y is 15. And the reason that happens is this thing here, this statement here, when we're using the equality sign, if we're in algebra, what we're doing with that equals sign is we're setting up a relationship between the variable x and the variable y, where we're saying, whatever x is, y is x plus 10. That's what we'd be doing if we were making that statement in maths. But in Java and programming, we're not doing that. All we're doing is saying, take this value, take the results of this equation, and put it into the variable y. So the only thing that matters at this point is, what is the current value of x? And the current value of x is 5, so y becomes 15. When we say x equals 10, that's only changing x. That's only setting the value of the memory location x. It has nothing to do with y. Okay? So that's why y doesn't change. That's why y stays at 15 down here. Okay? So the x equals 10 line still happens, but it's only affecting x. It's not affecting y. Okay? Cool. So this is an essential difference between, variables in algebra and variables in programming, is that in a lot of ways, the variables in programming are a lot simpler. They're just named locations in memory. Okay, so if you understood what I meant here about x is just a name for this memory location, then what I just said perfectly makes sense. That when you change x, but you don't change ride fare, or you don't change student name or whatever. Okay, so that's an important takeaway. Don't confuse the equality sign with anything that's going on in maths. It's not an equality, it's just an assignment. Okay, the other operators are, there's the usual suspects of addition, subtraction, multiplication, and division. They'll work exactly the same way you expect them to from maths, except that the symbols are a little bit different. Okay, plus and minus look as you expect. So this is going to result in, increasing x by 1, or this is going to result in decreasing it by 5. This is the symbol for multiplication. It's an asterisk, not a time symbol, because a time symbol would look like an x, and we use x as variable names all the time. So it's the asterisk symbol. Apart from that, it will work exactly the same way. So this equation is going to double the value of x. And then this is division. So it's just x divided by 10 there. Okay. Apart from that, they're all going to work exactly the same way you expect. So again, we could go in our coding, instead of y equals x plus 10, we could go y equals x times 10. Okay. So x is 5, y equals x times 10 is 50. Right. Will division clash with comments? No, because a comment is always two of those division signs, two of those slash signs, whereas division is always just one of those signs. So we could go, let's make this 50 x divided by 10, and that's still going to work just fine. Okay. There is one gotcha with division, but let me wait until we're talking about expressions before I cover that. There is one important thing you need to know about division, but otherwise it works the way you expect, which is just it divides numbers. Okay, I've got a note to cover that issue with division now. Okay, so the only thing to bear in mind with division is that if you divide two integers, I'll get on to what we're doing with strings, using the plus signs with strings in a second. But before I do that, let's talk about division with integers. So remember that x was declared as an integer and y is an integer. So let's say we've got x equals 10 and y equals x divided by 3. And let's comment this out because we're not dealing with that anymore. So when I print this out, you would probably expect x is going to be 10 and then y should be 3.33333 recurring, right? Unfortunately, that's not the case. It's going to round it down to y equals 3, and that's because y is only capable of storing an integer. What's more confusing is even if I change y to be a double, which, you know, this should be able to store 3.333 recurring, that's not going to work. That's still going to think that y is still just 3 with a 0.0 on the end. And the reason for that is, remember, it's making this calculation. This assignment operator is saying, make this calculation and put the value of that, the result of that calculation into this variable. It doesn't super matter that this variable is capable of storing 3.333 recurring. It's just Java will always, if you're dividing an integer by an integer, it's always going, the result of that calculation is always going to be another integer. It's always going to be something that can only store whole numbers. So when we do this, we're saying divide this integer x by this integer 3 and put the result, and that's going to create an integer. Put that integer into a double. We can do that. It's just it's only storing that whole number, but now it can, if we want, you know, we can add decimal values to it, like y equals y plus 0.1. So that's super confusing, I understand that. I'll explain why that happens in a second when I talk about expressions. But if you encounter this issue, there's a quick fix, which is you just need to make at least one part of this calculation be a double, not an integer. So we could say x equals, y equals x divided by 3.0. Now the results of this calculation is going to be a double because we're dividing an integer by a double, and we should have 3.33 recurring. Okay, so now it's properly calculating that value, 3.333. This is an indication of precision, by the way. So it's not storing 3.33333 all the way down here. It's only storing it down to 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, around about 16 significant figures. If y was a float instead, it would have even fewer significant figures. So, you know, there isn't a limit to calculations. If you need to do, like, you know, really, really highly precise scientific calculations, you know, most of us mortals won't have to do that. But if you're like working for NASA or something, you might need something even more precise than a double. But obviously we won't cover that in a foundation subject. Okay. You can, just like ordinary maths, you know, quite often you're going to want to combine multiple operations into a single equation. So here, you know, we've got x plus y times 10. And in that case, you know, just like in normal maths, that can result in some ambiguity about what happens first. You know, if we get rid of these brackets, then, you know, we'll get a different answer if we add x plus y together and then multiply the result by 10. That'll give us a different result than if we have x plus if we multiply these together and then add x, that'll have a different result. And so you can control the order that things happen in using brackets. So we can actually, let's recreate this scenario in here in code. And the brackets work exactly the same way that you are used to seeing them. So let's say okay, let's go double x plus 3 divided by 2. So if we do this, then we'll get a certain result. Okay, but if we change the order that things happen in, we might get a different result. Haven't road tested this, but we should. Okay, so the order that the additions and subtractions and divisions happen, the order that they happen in matters, and so you can use brackets to ensure that you get the right results, depending on the order that they happen. You know, if you wanted to, you could check the textbook about what the default ordering is. I think additions happen before subtractions, which happen before divisions or whatever. But to be honest, I never bother remembering the order. Like, if the order matters to me, if I know that there's some ambiguity in the equation depending on what order the operations are in, the best thing to do is just control it with brackets to remove any ambiguity. And then finally, addressing the, yeah, I think it is BODMAS, but I don't think it's not worth remembering that. It's just better to control it with brackets. Okay, so as we've already covered, and I think there's comments asking for clarification about this, the plus operator means different things when we're talking about, you know, the plus operator when we're working with numbers is obviously addition. The plus operator when we're working with strings is something different. It's called concatenation, which is basically, you know, taking two strings, two bits of text, and concatenating them together, just joining them together. So, you know, here we've got the name Bob, and we're saying name equals name plus 1. Obviously, it doesn't make sense to try to add the value 1 to Bob as a mathematical operation. Name is a string, Bob is a string, so when we put name plus 1, that's just going to concatenate 1 as a character and put it on the end of name. So that's just going to result in Bob1. Or, you know, tell me in chat, what does this result in? If I go string x equals 5 and I go x equals x plus 1, what is that going to result in? Yeah, 51, exactly. So it's not, even though this is a number, you know, 5 is a number, because we put it in a string, it's not recognizing that as a number, it's recognizing that as the character 5. And so we don't get 6 when we do that, we get 51. Okay. Doing good for time, yep. So the last thing I need to talk about this week is expressions. And expressions are basically mathematical equations. So whenever you use one or more of our operators like plus or minus or multiply or divide or concatenate or anything like that, basically you are creating an expression. This is an expression. An expression is basically work that your program is going to have to do when it runs. Okay, so this is a bit of work that has some input, x and 1, and when you run it, it's going to produce a value, which whatever the value x was, incremented by 1. So you can say that basically expressions don't initially have a value, or their value, depends on what x is or what y is or whatever the inputs are to the expression. But when you run them, they're going to turn into an output. They're going to be resolved into a value. So expressions always resolve into a single value. This is going to resolve into x incremented by 1, or if x was a string, it would result in x concatenated with 1. But whatever, it's going to be resolved into a value. And that value is also going to have a type. And that type depends on the variables and values that are involved in the expression. So we saw that here when we did what did I have in mind here? Well, we've got lots of expressions here, right? Like age, if this wasn't commented out, this is an expression which is going to result in age getting incremented by 1. And the expression, the value of the result of this expression depends on, the values, what value age is. So at the time that you're writing this code, you may not know what the value of the expression will resolve to, but it's going to resolve into a value when the program runs. This is a more complicated expression, and it's actually kind of a nested expression, because we've got an expression here that's going to resolve into a value, and then that resolved value is going to be input into this larger expression, and that is going to be resolved into a value. So you can nest expressions with using these brackets. Put expressions inside of expressions. The type stuff matters because, remember, we had that example where, this looks like it should result in a double value. The expression should resolve in a double. And if I'm honest, I don't know why Java didn't say that, when you divide an integer by an integer, it should resolve into a double, not an integer. To me, it would make sense to do that. But, the Java decision is that when you divide an integer by an integer, it resolves into an integer, which is why we had that issue with rounding. Whereas if you divide an integer by a double, or if you divide a double by an integer, then the result of that expression, the type of value that expression will resolve to, will be a double, and you don't have that rounding issue. Okay, so that's an example of how the types matter for expressions. Okay, so in chat, this is an expression here that I've highlighted. What do you think the type is that this expression will resolve to? We've got a vote for int. Do we have any other votes? Yep, so we've got a couple of votes for string. Yeah, so remember this expression, because this is a string and we're concatenating it with another value, it doesn't actually matter what type this value is. If strings are involved, it's going to resolve in a string, because it's going to resolve in a string that has the value x is 10, but that is a string. Okay, so this expression here resolves into a string. So, and it matters. For example, we could be trying to say, int message equals, we're going to put that expression, the result of that expression, into a variable and print out that variable. This won't work though, because this expression doesn't resolve into an integer, so we can't put the results into an integer. If I try to do that, I get this error saying on line 27, this thing, which is going to turn into a string, cannot be converted into an integer. So instead I need to make this thing a string, because that's what my expression is going to resolve into. Okay, and then that'll work. Oops, sorry. There. Okay. Okay, I had to go over expressions pretty quickly, but there's a good reading about expressions that'll explain it in a little bit more detail. But the basic thing is that, these expressions, they need to be executed by your program to get resolved, to be turned into a value, and that value has a type, and you can predict what that type is based on, what values and what variables are involved in the expression. Okay, so to wrap up with a little bit of housekeeping, the main thing you need to remember this week is that labs start this week. You should all have been formally enrolled in a lab. Like if you didn't choose which lab you wanted to, or hopefully you got a chance to choose which time you were in, you would have been forced to be allocated into a particular lab. Whatever the case is, you can find out the details of your lab. You should have a room number in your timetable system, but if you don't, the other place you can find out where to go and when to go is in Ed. If you go to Ed, you go to the lessons page, and there's an entry here called Everything You Need to Know About Labs. And in this, you have a lot of details about how the labs will work. Definitely read this before you go to your lab. But for now, the main thing you need to remember is where to find your room. And so it depends on which lab you're enrolled in. But if you're enrolled in today's lab at 11, you'll be tutored by David Dyer in this room. Okay, so hopefully you know how to read room numbers by now, but if you don't, this is the building name. So all of our labs are in building 11, which is the FEIT building, the one that looks like a giant cheese grater. This is the level, so it'll be in basement level 1, and it'll be room 100 in basement level 1. So check those entries for your room time and your tutor name. If you got forcefully allocated and the time really doesn't work for you for when to go to the lab, it is okay to drop into another lab. Okay, don't do this willy-nilly, because some labs might get too full or some labs might end up empty. But if you were forcefully allocated into a lab and you absolutely can't make that lab time because you're working or you have another class on or something like that, then it is okay just to rock up to a different room. Okay, no one's going to turn you away. Alright, what else about housekeeping? The lab exercises are due midnight Sunday. Okay, so your first deadline is this Sunday, midnight. The specific work that is due are the lab exercises, the assessed lab exercises. So you can find that work in Ed if you go to the lessons page and you go to the assessed lab, squashing bugs and manipulating variables. The intention is that you do this during your lab class time, but if you don't get it done during the lab, there's no problems. Or if you want to do it outside of the lab, if you find it easier to focus outside of the lab, that's cool. You can just do it in that link and make sure you do it before midnight Sunday or 11:59 on Sunday. You can submit it after Sunday, but you will lose 10% of the available marks every day that it's late. Um, your labs add up to 40% of your grade, and there are going to be 10 assessed labs, so each lab is worth 4%. It doesn't sound like a lot, but it's by far the easiest place to get marks in this subject. So definitely get your work submitted on time. Don't lose out on the easy marks. The other places you'll be able to get marks are in the assignment, which will be scaled to be significantly more difficult than the lab exercises, and the exam, which won't be scaled to be more difficult, but you'll have that time pressure. You'll need to complete it within a certain time. So yeah, don't miss out on the easy marks from the labs. Okay, apart from that, that's all I need to cover today, I believe. Next week, we're going to start talking about conditional statements, so how to make your program do different things depending on different conditions. Basically, how would you have a program that executes like a flowchart? In the meantime, make sure you're checking the readings before you go to your lab. Make sure you go to your lab, and make sure you finish the assessed exercises before midnight Sunday. If you get stuck at any point, obviously the labs will be a really good source for help. You'll get one-on-one time with your tutor, unless the labs are super busy, but most of the time you'll get one-on-one time. If you stick your hand up, there will be time during the lab allocated to giving people help with their lab work. But also ask questions on ed if you get stuck. The number one rule with asking questions on ed, though, I covered this last week, do not post code in your message, especially not if your message is public, but there's absolutely no good reason to post code for assessed tasks up on ed, because remember, teaching staff, I can just look up your code, and there's no need to risk spoiling assessed work for other students, or potentially having other students copy your work, which is not a good thing for academic integrity. Okay. Apart from that, all I ask is that you don't post up your code on ed. Just tell me which question you're stuck on and what error you're finding and that kind of thing, and I'll be happy to help. That's it for me. I will look through the chat and see if there's any burning questions I can answer. If you still have any questions, I'll stick around for a little bit longer and answer questions as well. Okay. I think we had a good discussion there about the types of expressions, and I think if you think about it, Java has to resolve expressions into something that is capable of storing the result, and if a string is involved, you can't take a string and turn that into a number or turn that into a Boolean. Or there are ways, but the programmer sort of needs to tell the system, okay, this string is actually storing, not just storing text, it's actually storing a number. As far as Java is concerned, it doesn't care, that you actually are storing a number in a string. It will treat it as just a string unless you explicitly tell it to do otherwise. So whenever you're adding things to a string, it makes sense that the result is always going to be a string, because it's always concatenating stuff with a string. The other mathematical operations, like I didn't demonstrate it, but it doesn't make sense to try to divide a string or multiply a string. The compiler will just complain and say that doesn't make sense to do. So if you've got a string involved in the expression, it's always going to resolve to a string. Isaac, yep. So I hope this is drummed into everybody now, but if you, with the assessed exercises and with the practice tasks and everything like that, anytime you see a mark button, you can hit that mark button as many times as you want. Hitting that mark button is a great way to get feedback about how close you are to the solution. So you shouldn't be at all reluctant to hit the mark button. Hit it as many times as you want. It doesn't matter if you pass, if you get your green tick on your first try or your 5th try or your 51st try or whatever. As long as you get that green tick before the deadline, you can hit it as many times as you want. Jessica, when you say you can look at your code on Ed, does that include practice labs and warm-up exercises? Yeah. So I can look at any code that you type into Ed. So it's okay to post up practice code if it's not assessed code. You can post that up in Ed discussion boards. There's no academic integrity concerns there. But again, it's not necessary. You just tell me which exercise you're working on, and I can look up what you're doing. Brendan, can we switch the type of a variable from int to double or vice versa without having to the point 0 to the int? Yeah, there is a mechanism for that. It's called casting, but I don't think we'll need to talk about that until we talk about defining our own custom types. Joel, yes, that's correct. Like 6 divided by 2 happens to result in a whole number. If you just did 6 divided by 2 without the decimal points, that would be 2 integers being involved in the expression. The result would be an integer, it would just be 3. But because you've included the .0 in there, that will resolve to a double. That'll be 3.0. The result will be 3.0. You can also just, whenever you've got a question like, what happens if I do this versus this, just feel free to try it out in Ed. Like any of the, inside of the readings, there will be, snippets of code. Most of those snippets of code will have a run button, and they'll be editable to you. So you can just make little changes if you want, edit it, hit run, and you'll find out whether that works or not. Or you can make changes into whatever changes you want to do, experiment in the practice exercises as well. Where can I see the lab reading again, please? Okay, let me do that. That one's important. So just remember, all of the lessons and readings are in Ed, and you go along to this lessons page, the one that looks like a guy reading a book, and inside of there, this is where you're going to find all of the important documentation, really. And the stuff about the labs is up here under how the subject works. There's an entry called Everything You Need to Know About Labs. And there's a bunch of readings. Everybody should read this stuff before they go to their lab class, especially the how pair programming works. And then the schedule, with the times and room numbers and tutor names is under when, where, and who with. Okay, any more questions? Okay, cool. If there's no more questions, I'll sign off and stop me if you've got a question. There we go, we've got a question. We've got a question from Seba. What happens if you try and use other operators like multiply and divide with strings? Try it and find out. Like, just edit one of those code examples in the readings and try it and find out. But basically, the compiler won't know what to do with that. It doesn't make sense to try to multiply or divide a string. So you'll just get an error from the compiler. Okay, I'll start the countdown again. Any other questions? Stop me if you've got a burning question, but signing off in 5, 4, 3, 2, 1. Okay, see you next week, everybody, and